Determine by inspection whether each system of equations has one solution, no solution, or infinitely many. Remember that infinitely many solutions occurs when the lines are exactly the same, and no solution occurs when they are parallel, or they have the same slope but different y-intercepts. So we're going to convert the equation from 4 into slope-intercept form so we can easily compare. 4/6 can be reduced to 2/3, so this is a slope of -2/3. And 42 divided by 6 is 7. Since the slope and the y-intercepts match, this is infinitely many solutions. Here, if we were to divide by 4, that would give us the equation 3/4 x plus 2/4 can be rewritten as 1/2. And for this one, we would need to move the 3x over and then divide by 4, giving us the equation -3/4 x plus 1/2. Since the slopes do not match, this is a one solution. Consider the system of equations. Lily, Vic, and Sean all rewrite the systems in different ways. Lily rewrites it so they have 5x in common, so they can substitute the 5x in one equation with what the 5x is equal to. Vic changes the 5x to a 2x by multiplying by a fraction. And Sean divides the top equation by 2 to get x all alone. Whose system would you use to find the solution? I would probably use Sean's system since all he had to do was divide the top equation by 2. What did the person do to rewrite the equation in the system you chose? Well, let's look at how they redid all of them. Lily multiplied the whole top equation by 5/2. For Vix, he multiplied the second equation by 2/5. And Sean divided the first equation by 2. Use your chosen system to find the solution to the original system of equations. In Sean's system, we have x equals 5/2y plus 1/2. So I'm replacing that in the second equation. The x gets replaced with 5/2y plus 1/2. And then we finish out the rest of Sean's second equation. I will distribute. 5 times 5 is 25. 5 times 1 is 5. I'm going to rewrite these as decimals. 25 divided by 2 is 12.5. And 5 divided by 2 is 2.5. Now I'm going to move the 3y over with the 12y. So that gives me 9.5y plus 2.5 equals 12. If I move the 2.5 over, I have 9.5y equals 9.5. And that gives me y equals 1. But I also need to plug it back in to solve it for x. So I had x equals 5 over 2 times 1 plus 1 over 2. 5 over 2 plus 1 over 2 is 6 over 2, which is the same as 3. So the coordinates of the point of intersection of these two lines is the point 3, 1. Abdul rewrites the system of equations from problem 1 in the following way. What did Abdul do to rewrite the system? He multiplied the first equation by 5 to turn the 2x into 10x. And he multiplied the second equation by 2 to turn the 5x into 10x. Solve the systems of equations by using the rewritten system of your choice. Check your solution. So we're using Abdul's here. The 10x is going to get swapped out with 6y plus 24. Subtract 6y from both sides. Subtract 5 from both sides. Divide by 19. And we get y equals 1. Then we replace the y value in one of these equations with 1. 25 plus 5 is 30. Divide both sides by 10, and we get x equals 3. And let's check it in one of those equations. 10 times 3, is that equal to 6 times 1 plus 24? 10 times 3 is 30. 6 times 1 is 6. And 6 plus 24 is 30. So yes, this point is a solution to our system. Consider the system of equations. Lily, Vic, and Sean all rewrite the system in different ways. Part A is going to ask us what system we would use to find the solution. And I'm actually going to say that I'm not going to use either of these three methods. Instead of substitution, I'm going to use the elimination method like I showed you in the other video. But we still need to answer part B. What did Lily do? Well, Lily multiplied both sides of the second equation by 2 and added the 8y to both sides. So you can see she doubled it to get the 8x, and she moved the y piece away. Vic multiplied the first equation by a half, and subtracted y from both sides. And Sean multiplied both sides of the first equation by -2, and added 16x to both sides. We're going to use our chosen system to find the solution to the original system of equations. So like I said, I'm using the elimination method rather than the substitution method. So this is my attempt at part C here. I notice that 2y and -4y, I can make those opposites. I can turn 2y into 4y, then 4y and -4y would be opposites. So I'm multiplying this whole equation by 2. That gives me 16x, 4y, and 8. Then using that second equation, right underneath, I'm going to add up all of these pieces. So adding the x's together, 16 and 4 makes 20x. Adding the y's together, 4y and -4y makes 0, so that's the elimination part of it. 8 and -18 make -10. Then I'm going to divide both sides by 20, which gives me x equals -1/2. Now we plug that back into one of these equations. Four times -1/2 is -2. Add 2 to both sides. That gives me -16. Divide by -4 on both sides. And that gives me +4. Now we're going to check that it is a solution by plugging it back into the other equation. 8 times -1/2 plus 2 times 4. Does that equal 4? Half of 8 is 4, but it's negative. 2 times 4 is 8. -4 plus 8 is +4. So yes, this is the solution to the system. In this one, it says, determine the number of solutions to the system of equations. If the system has only one solution, solve the system by using the substitution method and check your answer. We are going to use the elimination method. I notice that 4 and 8 can be turned into opposites. If I multiply this top equation by 2, that gives me 12x and -8y, and 12 times 2 is 24. Then the bottom equation can remain the same. Adding these together, I have 15x, a -8 and a +8 are eliminated. 24 plus 36 is 60. Then divide both sides by 15. And I get x equals 4. Now we will replace that into one of the equations. Three times 4 is 12. Subtract 12 from both sides. 36 minus 12 is 24. Divide by 8, and that gives me y equals 3. And we also need to check to make sure that we have it correct. So using the other equation, 6 times 4 is 24. 4 times 3 is 12. 24 minus 12 is 12. So yes, this is the solution. Here I have 6 and 8. 6 can be turned into 6, 12, 18, 24, 30, and 8 can be turned into 8, 16, 24, 32. So they both have 24 in common. 6 times 4 makes 24. But I want to make these opposite, so I need this one to be negative 24. 8 times 3 makes 24, but if I want it to be eliminated, I need it to be negative 24. 4 times 6 is 24x. 4 times 12y would be the 48y. And 4 times 15 is 60. Negative 3 times 8x is negative 24x. Negative 3 times negative 16 is positive 48y, and negative 3 times 20 is negative 60. If we add all these together, 24x and negative 24x is 0. Negative 48y and positive 48y is 0. I can't just leave the left side blank, so I do need to write 0 down. 60 minus 60 is also 0. 0 equals 0 indicates that this system has infinitely many solutions. So our book indicated that we should use the substitution method to solve these problems. However, a different method, such as the elimination method, may be more efficient depending on the problem. So pay close attention to the way that these problems are written, and if you would have to move a lot of things around to create an easy way to substitute. That's the end of lesson 9. Check back for lesson 10.